Welcome back, everybody. This is going to be the lesson that goes with DIY for section 9.3. And what you will need to do is tear this out of your section. You're only going to have to worry about, or out of your book, excuse me. You're only going to have to worry about the first page and the back of the first page. Do not worry so much about the Explore activity. That's the one that looks like this. Now, your guided practice is on the back of it, so you will have to tear that out. But you don't have to complete the Explore activity for this one. So this is lesson 9.3 in finding area of circles. So the first thing we're going to look at is Explore activity 1. Explore activity 2 is the one that you do not have to do. So it says you can use what you know about circles and pi to help find the formula for the area of a circle. Now, if you haven't done circumference or you haven't done the ratios and pi section, this may not be as simple for you to do as it is for some of the others. So, first thing you're going to do is use a compass and draw a circle and cut it out. Fold the circle 3 times as shown to get equal wedges. Unfold and shade one half of the circle. Then cut out the wedges and fit the pieces together to form a figure that looks like a parallelogram. The base and height of the parallelogram relate to the parts of the circle. Now, I do not have any compasses for you to draw circles. However, over on the table, there will be some circular objects that you can use as circles to cut them out, along with some small pieces of paper that you can use. So, the base and height of the parallelogram relate to the parts of the circle. So, see, this is how they did it here. So, our base, B, is 1/2 of the circumference of the circle, or pi times the radius. Okay, then our height is the radius of the circle. So that is an R. We represent our radius with an R. To find the area of the parallelogram, the equation is area equals base times height. You should be familiar with this one. So, to find the area of a circle, substitute for B and H in the area formula. So instead of B, we're going to do pi times R, like it is right here. And instead of H, we're going to substitute our radius, just like we did right here. Sorry, I pointed the wrong thing. So it's area equals pi times radius, which is also radius squared. So our formula for area of a circle is always going to be pi r squared. So I want you to pause the video and answer the reflection question. It's how can you make the wedges look more like a parallelogram? Notice they have some little kind of curved edges, so it's hard to see that it's really looks like a parallelogram unless you just kind of squint your eyes and tilt your head the right way. So, pause your video and make your answer, and then we'll compare it to what I've got. Alright, so it says, how can you make the wedges look more like a parallelogram? Make the wedges smaller so the base looks more like a straight line than curves. If you make each of these smaller, they're going to end up looking a little bit straighter, and then the straighter this line looks, the more like a parallelogram it will look. So, on the back of the first page, we have finding area of a circle. The area of a circle is equal to pi times radius squared. That's what we just found in our Explore activity. And our area is always given in square units. Whether we're finding area of circles, of squares, or rectangles, or parallelograms, or triangles, it doesn't matter. Area is always square units. So, let's look at example 1. It says, a biscuit recipe calls for the dough to be rolled out and circles to be cut from the dough. The biscuit cutter has a radius of 4 centimeters. Find the area of the biscuit once it is cut. Use 3.14 for pi. So, what you need to do is write your formula first. We always write our formula first. So then we substitute in what our radius is. They tell us the radius is 4. So we have area equals pi times 4 squared. Now 4 squared is not 4 times 2. Remember, that's 4 times 4. So when we make our next substitution, you get 3.14 times 16. And notice, just like in the circumference video, your area does the same thing. It goes from equal sign with the pi symbol to approximately when we plug in 3.14, because it's no longer an exact answer because we're rounding pi. So, the area of our biscuit should be about 50.24 centimeters with a radius of 4 centimeters. So pause your video, do your reflection questions, and when you come back, they'll be here for you to check. Alright, so So number 2 says, compare finding the area of a circle when given the radius with finding the area when given the diameter. So with our radius, we have to use pi r squared. If we're given the diameter, we have to divide it by 2 to get the radius before you can use pi r squared. Because remember, our radius is half of our diameter. On number 3, why do you evaluate the power in the equation before multiplying? Well, the reason is we have to follow our order of operations. Remember our PEMDAS, parentheses, or grouping symbols, exponents, then multiplication and division, then addition and subtraction together. So you have to follow that order. We do exponents before we multiply. Last one, you have to actually find the area. So you have a circular pool has a radius of 10 feet. What is the area of the pool? Use 3.14 for pi. So right here we write our formula. Area equals pi r squared. Pi is 3.14. Our radius is 10. So we have to do 10 squared, which is 100. And then 100 times 3.14 is 314 square feet. So this is your formula. All you have to do is plug in and substitute. You've got a couple examples here to go by. So your DIY for this one is to complete the guided practice, which is on page 300. If this was not helpful or you need a little extra help, make sure that you come in and get some help and request a workshop. That's what they're there for. Good luck, and let me know if you have any questions.